Welcome to this eLearn Security video on iOS attacking applications with Cycript. In this video, we are going to see how to use Cycript to attack custom applications in order to get sensitive information, edit the application properties, and bypass lock screens or password protections. We'll use a few different applications in order to demonstrate these different methods. The first application we want to attack is called LogMeIn. During our tests, we will assume that we don't have the source code for these applications. So we have to test the application in order to find information such as its methods and their implementations. So let's open the application and see how it works. Once it loads, we can see that the application has an option that allows us to remember the password. Right now the password is correct, so if we click Login, we are in the admin area. One of our first attacks may be to target this password field in order to discover the plain text form of the password. Right now we cannot get the plain text password from the device itself since every character is hidden and we cannot copy the text, but we could use Cycript in order to access the field's property and get its contents. So let's open a new SSH shell and attach Cycript to the application. We know the application name, so let's hook Cycript with the following command. Now that Cycript is attached, let's navigate in the application view until we reach the password field. First, let's access the Windows property and then continue recursively until we access its subviews. Here we can see all the objects in this application screen. We can see the object button, the text field, and the image. Here we are able to view the text property of this field, which is MyStrongPWD1234. We could also change the secure text entry property of this field in order to display the plain text on the screen. We just need to set it from 1 to 0. So let's access this object by setting the array index to 1. Here we can see we have selected the text field. Now let's change the secure entry value to 0. As soon as we press return, the text is displayed on the screen. This kind of trick is very easy, but we should also assume that not all of the applications allow us to remember the password. So we have to find a different method to bypass this password protection. We could try to display the admin area view without even trying to insert or get the correct password. To do this, we need some information about the application, and we can get that by using a tool called class_dump_z. So let's go into the SSH terminal and move into the application folder. Here we can see the binary of the application. Let's get some information about the app by launching the command class_dump_z logmein. Now we can see all the classes, the methods, and the properties set in the application. If we inspect the results more closely, we can see many items of interest. For example, we can see the name of the application delegate as well as the view controllers. We know that one of those is the view controller that manages the admin area. Since it's a very small application, we can be quite sure that the right view controller is the one called logged in view controller. Let's go back into Cycript and verify this information. With the command UIApp, we can get the singleton application instance, which is the centralized point of control for every application running on iOS. The UI application object has the responsibility of handling the initial routing of incoming user events, so it dispatches messages, maintains a list of all the windows, and it's typically assigned a delegate which we can access by adding .delegate to the previous command. This object is used to receive messages related to the app state, such as when it finishes launching, or when its foreground or background states change. As we can see, the delegate is called ELS LogMeIn App Delegate, which is of course the same that we obtained in the class dumpz output. One of the two properties set in app delegate is the view controller. A view controller is a vital link between an app's data and its virtual appearance. So whenever an iOS app displays a user interface, the displayed content is managed by a view controller or a group of view controllers. The information is useful to understand how the view controller is associated to the first screen displayed when the application runs. So now that we know that this view controller manages the first screen, we have to find a way to display the view controller named logged in view controller. So it is the one that displays the admin area. We can do this by changing the root view controller, which controls what is on the screen and provides the content view of the window. Let's first get its value in order to see what it returns. Right now, it should contain the view controller of the first screen. So let's run the command uiapp.keywindow.rootViewController. As we can see, it returns view controller, which manages the login screen of the app. To bypass this screen, we can change this value and force the OS to load the screen that we want, which in this case is logged in view controller. To do this, let's add to the previous command the following code. With this command, we are telling Cycript to change the root view controller with the new instance of logged in view controller. We can do this because we didn't access the view, so this instance has not been created yet. As soon as we confirm the command, the screen on the device changes and the admin area is now displayed on the screen. So without even trying to get the correct passcode, we have bypassed the login screen. Depending on the methods implemented in the application, there are other techniques that we can use to bypass a login. For example, let's change our target application and focus our tests on the application named LogMeIn2. First of all, let's get some information with class dumpz. Let's go back to the previous terminal and move to the LogMeIn2 application folder. In the same way we did before, let's run class dumpz against this binary. As we can see from the result, this application is very similar to the previous one, but this time it implements a few new methods such as verify pwd and call alert pwd. The first method may be designed to verify if the passcode is provided and provided correctly. Of course, it may be implemented in different ways. For example, depending on if the passcode is correct, it may directly call the admin view or it may return a value. From the method implementation, we can see that it's returning a value that is Boolean. So we can guess that the method checks the passcode and returns a 0 or a 1 depending on if it is correct or not. Let's attach Cycript to the app and then run the verify pwd. Now that Cycript is attached, let's run UIApp to verify that it works. Now we have to access the application delegate and then add view controller followed by the method name we want to execute. As we can see, it returns 0, meaning that the passcode is not correct. What we can do now is change this method by overriding its implementation and forcing it to always return a 1. To do this, we can use the following command: uiapp.delegate.viewController and then an arrow. The arrow is used to access instance variables. Then let's add isa.messages verify PWD. ISA is the pointer to the object class structure. So with this command, we are telling Cycript to access the verify PWD method. Now we have to write the new method implementation, so let's write equal function, open and close paren, squiggly bracket, return to 1, semicolon, close bracket. With this code, we are telling Cycript to overwrite the method with a function that always returns the 1. So if everything has been set correctly, if we call the method again, it should now return a 1. There it is. So now every time this method is called by the application, it returns 1, and we should be able to now access the admin area from the phone by clicking the button Login. Indeed, if we click the Login button in the application, we can see that it works. So we have successfully changed the method implementation, forcing the app to bypass the controls. Now that it doesn't matter what string we insert in the text field, the function will always return true. If we go back and change its returning value back to 0 and then try to log in on the device, we can see that it doesn't work anymore. In this video, we have seen how to bypass an application login screen with a few different methods. We have seen how to retrieve stored information from the objects in the view. We have seen how to bypass the screen by changing the root view controller. And we have also seen how to overwrite methods and force the application to avoid some controls on the passcode. Thank you for joining us.